Hello students, this is the Chapter 16 review, and we were talking about color in Chapter 16. Just some basics to begin with. Remember, there are two different ways that we talk about light. One is the additive process, one is the subtractive process. We have these diagrams for both here. The subtractive process is the one that you're probably used to in your everyday lives, and so that one's going to seem a little bit more intuitive. As far as terminology goes, we have to be careful about something. If I want to talk about colors, really I'm talking about the additive process over here. If I want to talk about the primary colors, I am talking about blue, red, and green. The secondary colors are cyan, magenta, and yellow. They are secondary colors because they are made up of two primary. Blue light plus green light gives me cyan. So cyan is now two of the primary, and so therefore it's a secondary color. When we're on the subtractive side of things, we have different terminology. And so if I don't say the word color, if I talk about a pigment, so a pigment is the thing that removes color. So that might be a paint, that might be the dyes in your t-shirt. Whatever it is that's removing color, we call that a pigment. If I want to talk about the primary pigments, it's magenta, cyan, and yellow. Those are primary pigments because they only remove one color. So cyan, for example, removes the red. You can always look at what's opposite. So cyan is going to remove red, yellow removes blue, and magenta removes green from whatever's going on. That's why it's subtractive. Keep straight that these get flipped a little bit. The primary pigments are cyan, magenta, and yellow. Secondary pigments are blue, red, and green. But if I go over here to the additive side, they are flipped. So the primary colors were blue, green, red, and the secondary colors were cyan, magenta, and yellow. Just to make sure you understand the additive diagram, we are saying that if I was in a very dark room and I was shining light on a white wall, and I shine green light, so here's now a green spotter, this is a laser pointer, something like that. And then I shine red light over here, and there's an overlapping portion right here. What we would see in that overlapping portion is yellow, and that's what's being demonstrated up here. That I would actually get yellow if I added some additional color. If I added my third primary color, blue, and I look at the region of overlap, that's where I would get white light. So we say that when we're in a room that has white light, or we're outside underneath the sun, we have all three primary colors available to us. If I start removing some of those primary colors, that's where I get into the subtractive process in pigments. So let's say I have a blue shirt that's sitting here, and I'm out in the sun. So that means that I have all three of my primary colors coming in. They're striking the shirt, but not all of them are able to make it away from the shirt. Blue light is going to be reflected off of a blue shirt, and it's going to go into my eyeball, and I'm going to see blue. The red light and the green light, they both are going to get absorbed into the pigment, and therefore subtracted out. That ultimately the energy from that light is going to go to heat, and that's why you're going to start to warm up a little bit when you're wearing your blue shirt. If I had a white shirt over here, I would have these three different colors coming in, and all three of them would be reflected off here. And so if I was looking at the white shirt, then I would see all three still, and I would still see it as a white shirt. That more reflective color, white, that means that it's going to be a cooler shirt when you're outside. Certainly if I had a black shirt on, what it means is it's absorbing all three of the primary colors. When I have the absence of light, that's black. That's what's actually being shown in the middle part of the subtractive process. I have black in here, you can't see me writing over it, but I have black in the middle there because all of the primary colors are gone. The absorption of that blue t-shirt is certainly true and it's useful, but we also like to use our array diagrams in this class so that we can have a cleaner way to look at what's going on. And so if I have all three of my colors, so this is white light back here, going through a B for blue slide, what I can show is that only blue light will be able to pass through and make it to my eye, which is sitting over here, and so I'm going to see blue light. The other two colors were absorbed in that process. Again, if I come up here and try to talk about blue being a secondary pigment, it's secondary because it blocks out 1, 2 primary colors. A primary pigment, so let me draw a new set of my colors over here, and if I want to pass that through a primary pigment, let's pick yellow. It's a primary pigment because it only blocks one color. It happens to block blue, so the green light's going to make it through. The red light also makes it through. And so I would see the combination of red and green was yellow that we talked about before. If I were to put another slide up here and ask that remaining light to go through another slide, let me just pick a color. I'm going to pick cyan. Cyan allows green and blue to pass, and it blocks red. My red's going to go away now. It's going to be absorbed. Green is still allowed to pass. Blue would have been allowed to pass, but it never reached out there in the first place. And so if I look at this now, I would see green. Come up to this subtractive color thing again here. So if you were to try to make green on paper from a color printer, the color printer has to put down both yellow to get rid of blue and cyan to get rid of the red. These diagrams that I've been drawing here, I used to say in class, are an all or nothing thing. We're assuming that all of the color gets blocked out. At one point we used to talk about how do we resolve this idea that when I'm in art class and I mix red paint and blue paint together, I get purple. And how can we resolve that? Let's maybe say this is real life here. In real life, what I'm going to do is I'm going to put a slide down. I'm going to show that I'm blocking some light. Let's have this be a red slide here. And then I'm going to have it pass through another slide. And this is going to be blue. And in real life, if I were to do this, or if I was mixing paints, red paint and blue paint, I'd get something that looks kind of purple. And what we're going to do in order to mimic real life is we're not going to allow all of our color to get absorbed. I'm going to use a dashed line to show that half of it's getting absorbed. So a red slide allows red light to pass through. That is unchanged. It's going to make it out and it's still full intensity. Then I'm going to have green. Well, green gets absorbed by a red slide, but instead of allowing all of it to go away, I'm going to allow it to just become a dashed line, and so that means that half of it went away. Red also absorbs blue, and so it's going to cut that down to half intensity. Then we get over here to this blue slide. Blue only allows blue to pass. So blue is going to pass at its half intensity. Red gets blocked by blue, but I'm going to cut it down to half intensity. And then we're going to have green, which gets blocked by red, but also gets blocked by blue. I'm not going to allow it to pass. It's going to get totally wiped out right here because it was already at half intensity. And I come over here and I have my eyeball and I say, what color do I see? Red and blue, but at some lesser amount, some lesser intensity. And what do we get when I have red and blue? We get, in physics class, magenta is what we call it, but in art class we might refer to that as purple. Let's do the same thing again, but let's do it how I want you guys to be treating it in our physics class with this all or nothing business. Let's take a look at how we want to do this in our physics class though. We're going to do the same example, so I'm going to have a blue slide here and then a red slide. I don't remember if that's the same order I went in, but remember the order doesn't matter. Blue to red or red to blue, it's going to be the same result in the end. Now, when we're doing this in physics class, we're going to say the only thing that passes a blue slide is blue. Okay, the other two got totally cut out. And the only thing that passes a red slide is red. Now, red would have passed up here, but it didn't even make it to that point to begin with. Blue is going to get blocked at this red slide. It's not going to make it through. And so in physics class, I'm sitting over here and I don't see anything. And what I get is black. I get the absence of any color. All right, we'll look at our last thing that we've talked about, where let's say that I have a street lamp out here and it's putting out yellow light. That would be kind of common for a street lamp. What that means is that it puts out red light and it puts out green light, because that's how I get yellow up there. But it's not actually putting out any blue light. And so if somebody walks by and they have a blue t-shirt on, what would we see as this light goes through? Let's do a ray diagram to show this. I'm going to start with my red and my green, but I'm not going to put in my blue because I don't even have any blue. And it's going to go through and it's going to hit a blue shirt. Normally, if I did have blue, blue would pass through a blue slide, but it's not here. So my green goes away and my red goes away. Nothing is able to pass, and so I would get black over here when I'm looking at it with my eyeball. What does this mean? It means literally if you were sitting underneath a yellow street lamp in a blue shirt, it would very much look black. You wouldn't actually be able to see any color associated with it. Let's say that this same person, or a different person, is going to come through, and I'm just going to pick a different color here. Let's say that they have or let me pick magenta in this case. So we're going to come through. I'm drawing this as a black shirt. I don't have a magenta marker, but this is M for magenta. So now I have a magenta slide. Magenta blocks green. That's the only thing it blocks, though. So my red light would be able to go through here. Magenta would allow blue to go through, but again, I don't have any blue in the picture. And so red got through. It gets over here, and what do I see? I see red. Okay, so if I have a magenta t-shirt on and I'm underneath a yellow street lamp, it's going to appear to be red. That's all I had for color. I think that about covers it. You do need to have those two diagrams in the top memorized if you don't already, because that'll really help you out. But other than that, if you think you've got it, let your computer know.